Today's lesson was 1.6, the point slope form. The lesson started out with a graph, and on that graph there was a particular point. I think they gave you 4, 2. And then they asked you how to get to a point. If they said you change your x to 11, what's the new point going to be? And they had also given you this constant rate of change formula, that the change of y is 3 times as large as the change of x. So first of all, we just had 3 steps we had to do. We had to find the change in the change in x. That was my new x minus my old x, so 11 minus 4 was 7. The next thing I had to do was find the corresponding change in y. So in this case, it's got to be 3 times as large as whatever change was in x. 7 times by 3, or 3 times by 7, was a change of 21. Finally, third, you had to identify what the new point was. I'm going to show you 2 ways here. You can lay your point out for 2. The change in x is plus 7. The change in y is plus 21. The reason I say plus and not minus is these are positive 7, positive 21. So do exactly what the change says. And the new point was going to be 1123. You could show this point on the graph. So we've been talking a lot about showing the change in x. Here's my change in x. That went 4 plus 7 got me to 11. And then the change in y was 21. 2 plus 21 gets me to this new point at 1123. The next thing it asked us to do in our notes was then say, okay, that's how you get to the point x equals 11. What if I just said for any value of x? So it gave you something to model off of, and then we had to do the same steps for just x. So on the graph, I'm just going to plot a point on the graph. Let's call this point x. So to get from 4 to x, I'm going to do my first step. The change in x is going to be my new value minus my original starting value. So my x minus 4. Once I know the change in x, I can calculate the change in y. The change in y is found by saying 3 times the change in x. So 3 times by x minus 4. Next, I need to calculate the value of y. Notice that the value of y here was found by taking my change and adding the y value. So on this one, I'm going to take the change in y and add my original y value of 2. Here we have a formula. And what we had come up with really, and I really like to write the y on the other side. Let me rewrite that. What we really discovered here was the point slope formula of this line. My slope is the 3, the constant rate of change. And then my x minus 4 plus 2, positive 4, positive 2, there's my original point that I was given as a reference point. Now, in a lot of math textbooks, you'll see the point slope formula written as y minus y1 equals m x minus x1. This relates back to the idea that we've been talking about in class. The change of y is equal to constant m times by, let's make that a triangle, delta x, the change in x. Changes are found by subtracting 2 values. So y minus y equals m, x minus x. In this text, and the notes have us go ahead, instead of always having to plug in and then move the y over, we're just going to go ahead and move the y right from the get-go. So the formula you wrote down was y is equal to m, x minus x1 plus y1. M here is my slope. Keep in mind that slope is rise over run. This is the same thing as the change in y over the change in x, which is the same thing as y2 minus y1 over x2 minus x1, which is the same thing as saying the constant rate of change. All of those are the same thing. Let me scoot this up just a little bit. Now the x1 and the y1 are our reference starting point, or our known value. And then this x and y without the subscripts, these are what you're going to move to. They're the new values that you're looking for. So that's a little bit about the point slope form. The next video is going to discuss 3 ways that we can use this.